stuff that's in the notes. I think we sort of talked about where this would go a little bit yesterday, but didn't finish it. And I don't know, we may not have even talked about it in this class, so we varied a little bit. But what is the LCD for these two things? 2 minus x times x. Okay, cool. So multiplying the whole thing by both 2 minus x and x. First part of the product here, what happens?
2 minus 6 cancels out.
Then we're left with?
X times it.
Okay. We multiply those, x cancels, and we're left with 2 minus x times 2. And then on the right-hand side, we're just multiplying by 5. So 5 times 2 minus x times x. Oh, yeah, and with all this, thinking about the domain question, right? X cannot be two or 0. Okay, then just solve this. So we find the LCD, we multiply through by it, fractions go away. Now we just solve this, let's see, looks like it's going to be quadratic. X squared, distribute here. So 4 minus 2x. And then on the other side, let's do this in 2 steps maybe. 10 minus 5x times another copy of x, so 10x minus 5x squared. And since it's quadratic, to solve, we need to move. Oh, do you know what about solving quadratics? Right, okay, good. What that, like, my goal here really is that that becomes an involuntary response. Like 5 years from now, somebody says the word quadratic in a movie or something, and you just shout everything, like you can't control it. I'm playing the long game here. So move everything to one side. Six x squared minus 12x plus 4 equals 0. And that, to me, looks like a place to use the quadratic formula. It might, I don't think it's going to factor. No. Then even if it does. All right. Negative b squared 4ac 2a. 4 times 6 is 24, times 4 again is 96. Over 12. Okay, yeah, so this is not going to be, it's not going to have, pretty solutions. Square root of 48. 48 is 2 and 24 is 2 and 12 is 2 and 6 is 2 and 3. So a 2 and another 2 and a 3 left behind. Okay, so 12 over 12 is 1. And then 4 over 12 is 1 over 3. So square root of 3 over 3. And those are fine because this was undefined, or one or more of those pieces were undefined at 0 and 2, and these are definitely not 0 or 2. Right, so again, just thinking about the domain question. Okay, so 1 plus or minus root 3 over 3. So solutions are messier, right? I put this problem here on purpose just so that we haven't forgotten about quadratic formula stuff, right? Am I going to write this into a test question? Probably not, but you ought to be able to do it still. Right?
Yeah. Are you going to put it on the test like last time or no? The quadratic.
Oh, the quadratic formula. Ooh, it's not. It hasn't been on. It hasn't been there in the past. But at the same time, okay, yeah. Let me run it by the team and make sure everybody's cool with that. But yeah, I mean that makes sense. I don't know why we would give it to you sometimes, but not other times. I still don't really care if you haven't memorized. Yeah, so I'll keep that in mind. Yeah.
Thank you.
Okay, so apart from the fact that like this part was a little bit messy, but like in a familiar way, right? Do anybody have any questions about that one?
Would that be 2 separate x's, like x equals 1? And
Yeah, so 1 plus root 3 over 3 and 1 minus root 3 over 3. Yeah. Okay, the one I really want to actually talk about is this one. So yesterday we talked through that negative exponents mean reciprocals, which means that this thing is really this thing, right? And then I said, hey, go home and do this. Okay, so there are a couple of ways you can work through this. And let's just, start with what you see maybe. So the LCD here is x to the 4th, right? We've got x to the 4th, we've got x squared. So the smallest thing I can, take all the denominators up to is x to the 4th. And x can't be 0, right? Okay. All right, so how would you like to go about trying to solve this thing? Okay, multiply the whole thing by x to the 4th. All right, so here you get 1. And here, x to the 4th over x squared. So I've got 4 copies in the numerator, 2 in the denominator, so we're going to end up with x squared. And then minus 4x to the 4th, and then on the right hand, 0. Okay, now what? That part's a little intimidating, right? Okay, it's a degree 4 thing. The amount of stuff, the number of degree 4 things that we can solve is pretty small. We can't do them in general. Brad pulled up the big scary formula at some point, right? Like there is a formula, it sucks, we're not going to use it. Which means that if we can solve this, it's got to be, one of a very small number of cases. Like either there's a common factor and we can reduce it to a thing that's not really degree 4. Are there any common factors here? No. Okay. Or if not that, then it's got to be something that we can treat like it's quadratic, right? That we can factor or use the quadratic formula on. And oh look, 4th power, square, constant term, or like 0 power, right? So it's got that sort of like double, single, zero, like pattern kind of thing, like a quadratic, right? This is the thing where it's quadratic in form, so we can treat it like it's quadratic. The adjustment that we make is instead of x, everything's in terms of x squared. Right? So one way to solve this would be to, I'm going to start by rearranging stuff just to get them in descending order, right? It's sort of backwards right now. And I don't really want to have to deal with the negative coefficient here. So I'm going to move everything over to the other side and rearrange. So 4x to the fourth plus 3x squared minus 1 equals 0. So it's quadratic in form, only, all the powers are double what we're sort of used to dealing with, right? Or what we expect from the quadratic. Quadratics go square term, linear term, constant term. This is fourth power, second power, and then the constant term. So all the powers are double. That's what I mean by this, right? Everything's in terms of x squared. So what I could do is try to factor this like it's quadratic, only when I factor it, I would factor it in terms of x squared. And then solve in terms of x squared, and then figure out what x is by taking a square root eventually. But this 4x to the fourth, having that leading term, especially leading term that's not prime or factors uniquely, makes the factoring part kind of more difficult. If you're comfortable with that factoring, then by all means go for it. It's not that bad here. Or we can use the quadratic formula. The difference would be that it's in terms of x squared. So negative b, square root of b squared. I'm going to start writing less for the quadratic formula, if that's okay. B squared is 9, 4ac over 2a. So that's 9 plus 16, which is 25, and the square root of 25 is 5. Okay, so we get negative 3 plus 5, or negative 3 minus 5. And those reduce to 1 over 4 and negative 1.
Wait, so I did it before and I didn't change the negative to a positive four and
Uh-huh.
times 3.
You get the same thing. You would end up with,
I thought negative 1 and negative 1.
so yours should look like that then, right? Yeah. So that would be 3 plus 5, which is 8 over negative 8. And 3 minus 5, which is 2, or negative 2 over negative. So you should end up with the same things here.
Oh wait, I have a negative 8 at the bottom.
Right. Yeah, so your negative's in the denominator instead of the top, but you should end up at the same place once you simplify.
3 plus 5, 8 divided by negative 8.
Uh-huh.
Okay, that's
Which is negative 1. Yeah. I can come take a look at it in a second. Yeah, it should work out to the same thing. You just have you'd have the negative here instead of in the top, but it'll be the same thing. Okay, but that's x squared, right? So x squared is 1/4, which means that x is plus or minus 1/2. And on the other hand, x squared is negative 1, which means that x is plus or minus I. Most of the stuff that we've seen, and like it doesn't come up in the homework anywhere, that you get a thing with complex solutions. So these would be kind of the ones to focus on, but like those would be this has 2 complex solutions as well. None of those are 0, so they're all sort of okay. If we're looking for real solutions, it'd just be these two. Now, another way you could do this thing would be to just do that kind of right off the bat. And this would be more of a like start by noticing a thing, which I know is not always something that we catch, right? Because the problem if the first step is notice is what if I don't notice? I can write that thing like this. 1 over x to the fourth is the same thing as 1 over x squared squared. And 3 over x squared is the same thing as 3 times 1 over x squared. And the reason I'm doing that is to make it look like a quadratic, right? This thing's quadratic in terms of 1 over x squared, which means if I could factor it, just normal trinomial factoring stuff, or use quadratic formula, which things that multiply to -4 and add to -3, -4 and +1 would work. And then this thing factors in terms of 1 over x squared, just like that. Which means then, since it's factored, 1 over x squared could be 4, which means that x squared is 1/4, right? Just take the reciprocal of both sides, and then you get plus or minus a half. Or again, take the reciprocal, but the reciprocal of -1 is still -1. And again, plus or minus I. Now, that's a little more direct, right? But it depends on, again, me noticing something first, right? So, especially when you see things that seem, maybe out of nowhere. Like if you go back and look at the original problem here, which is somewhere, like it doesn't feel like it fits in with everything else, right? Often in cases like that, something to think about might be this sort of quadratic form idea. We'll do some more with this next week where it's maybe a little more apparent from the beginning that like this is a technique we might try, but that's what it would look like here. Again, either way is perfectly fine. You don't have to do it one way or the other way. So kind of whatever makes more sense to you. And again, don't hold me to this. I don't think this week's homework, anybody know? Surely someone has finished the homework.
Yeah.
Or maybe not. Okay. Did anything like this show up I don't think anything like this shows up in this week's homework. There are some in next week's. But again, we'll come back to that and kind of look at it some more there.
It does have some great. I had a fraction with 1,000 over like 100.
Okay, yeah,
that was correct.
Yeah, some of them, whatever their algorithm is for writing the problems, some of them the answers do come out to be kind of weird thing, but they should always be from like solving a linear equation or something like. So it's not some crazy quadratic thing where the solutions are you're simplifying the square root of 968 or something. It's not that kind of thing. It's just it ends up being a weird fraction. Yeah. Okay, so there's that, and again, we'll circle back to this idea next week and kind of look at it some more in that context. All right, inequalities is the last piece of the puzzle here. Last thing we need to figure out. So look at whatever that first example is. X plus 3 over 2x minus 1 greater than or equal to 0. Basic idea is going to be the same as everywhere else we've looked at inequalities, right? An inequality is like a true or false question. We're trying to find x values that make this true, right? So we're going to figure out places where the answer can change, right? Just like we have. I'm going to draw a number line again. I'm going to mark those. I'm going to test points or graph or think about it somehow. and draw happy faces and frowny faces and stuff, and then we're going to write down a solution, an interval notation that describes where this thing is true. The only thing that's new is what a rational expression kind of brings to the conversation, right, and how that's different. So let's take a look at that one real quick. Y equals x plus 3 over 2x, that's a y, 2x minus 1. Okay, here's that function. What are we comparing it to? 0, right? We want to know where it's greater than, less than, or I don't know, greater than or equal to 0. Okay, y equals 0 is right there, right? The x-axis. So we're comparing it to that line. And we want to know where it's greater than. Is it greater than? Sorry, I didn't make that sound like a question, but greater than or equal to. On the graph, greater than or equal to means above. Okay, so where do you see it sitting above the x-axis? Here and here, right? Okay, where does it cross, or where does that change? There's this point here where they intersect, right? -3, which is an x-intercept, right? Just a point where the thing crosses. Where else does it change? So reading left to right, it's sitting above the y-axis, or the x-axis, sorry, sitting above the x-axis, curving down. We get this x-intercept where it crosses, and then it's below for a while. But then all of a sudden it jumps up there, because what happened? There was a vertical asymptote. And then after that vertical asymptote, it's sitting above the axis again, right? Okay, so where do things change here? The x-intercept, because of course they do, right? Because an x-intercept is where the thing is equal to 0. And where else? The asymptote. So what do we need to figure out? Places this can change, from being true to false or false to true or whatever. The things that we need to check. X-intercepts. Because x-intercepts are really just solutions to that equation, right? Go look at all the other places we've done inequality stuff. That's what we found, right? We set it equal to 0, we solved, we took those points. So there, and where else? Vertical asymptotes. Hey, I don't remember, are we like really good now at finding x-intercepts and vertical asymptotes? Yeah, we are. Oh man, good news. Okay. So where does this have x-intercepts? How do you find them? Set the whole thing equal to 0. That means setting the top equal to 0. That gives you -3. What about vertical asymptotes? Set the bottom equal to 0. Vertical asymptotes happen where the thing's undefined in a way that gives you like number divided by 0. Set the bottom equal to 0. So x is 1/2. Okay. If this has one and only one x-intercept at -3, and one and only one vertical asymptote at x equals 1/2, then the only places that the answer to this question can change, right, from being yes to no, or true to false, or whatever, would be here and here. Which means there are 3 intervals. The stuff before -3, the stuff between -3 and 1/2, and the stuff after 1/2 that we need to make a decision about, right? So all that we do is test this inequality on those intervals. Now you can do that numerically, right? You can plug in a value and see what happens and decide, is it positive or negative? Is the inequality true or false there? So I could plug in like -5 and 0 and 2 or something and just, check the inequality that way. We could do it graphically. Here's what it looks like. Now, when we did like quadratics and polynomials and stuff, we had a better idea just right away of what the thing looked like because, a quadratic, right? Leading coefficient positive, boom, it looks like that. Okay, so, positive, negative, positive, or like whatever. I don't have quite the same feel for just looking at this and knowing that it looks like that, right? Like I don't even, have that just right off the bat ready to go. But you do, it's hold your calculator really high. But you do have a thing that will tell you what the graph looks like, right? So you could do it that way. Here's the function looks like this, right? Whatever you're more comfortable with is fine with me. If you want to plug in points, there's only 3 intervals there, right? That's not going to be that much effort to just plug in and see what happens. -2 over -11 is going to be overall positive, right? Or if you're okay with seeing it from the graph that, it's got positive y values, that's all we're looking for. At 0, 0 plus 3 is positive over a negative. So overall, that's negative. At 2, 5 over 3 is positive. That's all we're looking for. Yeah, right. Like if I plug this in, I get 3 over -1. Overall, that's a negative number, right? That's what I mean by positive and negative. And the question was, where is this greater than or equal to 0? So on this interval, the inequality is greater than. So we should include that stuff then. The next interval, in between the two, it's negative. That means this is not true, right? It's less than 0 there, so throw that stuff out. And then the next one should also be part of our solution set. Which we are now ready to write down. As an interval or union of intervals, whatever is appropriate, what's the solution set here? -infinity to -3. And just don't worry about the closing thing for a second. We'll come back to that. Where else? Union. 1/2. Positive infinity. Okay. Now what about the endpoints? The question was greater than or equal to, right? What happens at -3? They're equal, right? At -3, 0 equals 0. So -3 should be closed, included, bracket. What about 1/2? There is no 1/2. Thank you. I like that. There is no 1/2. At 1/2, the function's undefined. There's a vertical asymptote there. So what should happen at 1/2?
Oh, crap.
It's got to be open.
You didn't make me look confused.
Because even if I try to plug 1/2 into this thing, what happens? I get something undefined, right? Is something undefined greater than or equal to 0? No, it's not a number, so it doesn't even make sense to make that comparison, right? Okay, so vertical asymptotes then can't ever be included here,
Okay.
right? Kind of no matter what, right? They've got to be open. Because think about the domain. The thing that we're writing down here is a subset of the domain, right? The domain of this function would be -infinity to 1/2, open, union 1/2 to infinity, also open, right? I can't include 1/2 in this if I can't include 1/2 in the domain, right? So it's the same idea. So that can't be included. This one can and is here because this said greater than or equal to, right? The next problem, strictly less than. I don't know what the answer is going to be yet, but all of the endpoints are going to be open, right? Because it's strict inequality there. Everybody see the difference? So
all
yes,
the-
there's kind of like one extra layer to that. But
So all the vertical asymptotes will just have just a normal.
yeah, right. Vertical asymptotes would never be included because they're not included in the function either.
Okay, that's not that bad.
Yeah, no, it's not that big a deal. I know it's an extra layer to it, but. Okay, so let's recap. We need to know where the equation's true, right, as usual. That means here finding the x-intercepts because we're comparing to 0. And then vertical asymptotes because kind of anything can happen on either side of a vertical asymptote, right? So we just check. You've seen functions at this point in homework and stuff that, do that around a vertical asymptote. So it doesn't have to change, but it can change. That's why we go check and test, right? So if this happened, I would just say, okay, well, it's positive here and it's positive here. And okay, so I guess they're both included. But the point is that I don't know that ahead of time, right, going in. So we're finding the places things can change and then seeing what happens, right? And then, as usual, we'll just write that down. Okay? All right. We got about 15 minutes left, and this problem ought to take, a few. So let's take, part of this time. Y'all work on this, and then we'll talk about it all together. I'll just leave this here.
This is the graph you greater than. Yeah. Less than. Just looking at the graph, we already got this area, so we know this first part is correct. Yeah, it's really tiny, but it's negative so. So everything's gonna be.
So for this question, find the vertical
This is the beginning of
that
the brain, the homework.
with x
So holes happen when it's a zero at the top and the bottom. So like if you factored this and 1 equals the x minus 5, then 5 would make top and bottom 0. 0 over 0 is when you get a hole. So
Okay.
since you got 5 as your x-intercept and you got negative 1 and 2, this has two vertical asymptotes at negative 1 and 2. So the graphs are like three chunks.
Got it.
Yep. And it just,
So it would just be like.
Yeah.
Like that.
yeah, and you just check those four, or decide on those four.
And that'll only, that is changing time. Correct. For sets.
Yeah, maybe.
Okay.
Yeah, like it we don't think that,
Mhm.
right? But there are, instead of this had 1, 2, 3 intervals that, it may or may not work on. It turned out that it worked on 2 of them.
Got it.
This has 4 that may or may not. Okay?
Okay, perfect. And also for the test results?
Yeah.
Can I come by your office? to
Sure.
check? Okay.
Of course.
Okay, perfect. Thanks. Okay. So this is what it's saying. Is we have our chunks here. We have to solve for each.
So, intercept or asymptotes are negative.
Especially by a lot of people, like,
So you want to be testing.
Do we have to look at the questions?
There's an asymptote there and there's an intercept of 5. So you want to be checking here, here, here.
But I don't know if that's something that.
So if you can graph that,
And then
make sure it does
if we solve for each of these,
step
check the one that meets that requirement. That's how we pick it up. But hypothetically.
Now you can do it to that.
Whenever I
But
test it.
what you need to know is something out here is it's involved in
That's good to know.
So if you're okay with reading from the graph, right? That's 2 is right here, 5 is over here, right? So that's above. And then it crosses, and that part's in subtle to the graph, right?
Yes.
So now that it makes intercept there, it does actually cross.
So,
Like if you're not,
zero or
if you're
negative
not
2?
comfortable with that, right?
Got
It's
it.
not gonna be really.
So we really were on
Take
something
negative
for
2,
us.
Okay.
plug it in, you go back to calculator 2, just type in 5 minus negative 2 over negative 2. And then all you're looking for is, when you hit enter, does it give a stop or no? That's all you're doing. To get a yes or no. This is like this one.
Where? So then where's the big range?
Yeah, and just make sure to think about what the inequality is. All right, x-intercepts.
Five, because if you set 5 minus x equal to 0, you get x equals 5. Vertical asymptotes. -1 and 2. Because this thing factors as x plus 1 times x minus 2. Okay. Which means we have 3 points to consider to, test around -1, 2, and 5. There's a vertical asymptote here, there's a vertical asymptote here, and then there's an x-intercept here. So what we need to do is make decisions about the function on these 4 subintervals, right? So check something like -2 and 0 and 3 and 6. You can do that graphically. You can do it numerically. It doesn't really matter. We kind of did the last one with the graph, so let's do this one by plugging in these test values and checking that way, just so we've kind of done a little bit of both. If x is -2, again, all I'm going to do is plug into the inequality and see if it's true or not. You could just type that whole thing into your calculator. 4 plus 2 minus 2 is 4. Is 7/4 less than 0? No. So that statement is false then on that interval. All right, whatever happens at -2 is going to describe anything that happens out there, provided we got these right, and we did. So that inequality, that statement or question is false out here then, so I should not include that in my solution set eventually. 0, 5 minus 0 over 0 minus 0 minus 2 is 5 over -2 less than 0. Yeah, that's negative. That's going to be part of my solution set. And then so on, keep doing the same kind of thing. 3, 5 minus 3, 3 squared minus 3 minus 2. So 2, 6, 4, I think. Is that less than 0? No. And then 6. 5 minus 6. 6 squared minus 6 minus 2. -1, 36, 30, 28. That's negative. So yes, because the inequality was less than 0, right? Again, don't read into the fact that it's alternating, right? It's just what happened here. And then write down an answer, right? Solution set is everything that we just shaded or everywhere that we decided the inequality was true. So that's everything between -1 and 2. And everything bigger than 5. And then again, think about the endpoints. What happens at -1? A vertical asymptote. So no matter what, -1 can't be included. What happens at 2? Same thing. So 2 is not included. What happens at 5? An x-intercept, which means this is 0, but do I want to include 0 less than 0? No, because it's strict inequality, so that one's open as well. This is the only one that would change if that was less than or equal to. Right? Okay. Questions? Okay. So, again, the only thing that's sort of new is that because we're dealing with rational stuff, we get this extra layer of things, right? And even think about vertical asymptotes and what that effect that has on the parentheses versus brackets thing. Okay, so you have homework due on Sunday. Hopefully you're well on the way already. But if any last minute stuff comes up, of course, feel free to email or take the hit and come talk to me about it Monday morning. You have, or if anybody came in late, make sure to grab a copy of the Week 10 stuff on the way out. The video's up. Make sure to watch that so we're on the same page for Monday morning. And I will see you all then. Have a good weekend.